All right, guys, welcome back. We're moving on to activity 30.2. Before we do that, we're going to run through numbers 10 through 15 from 30.1 real quick, just to make sure you're on the right track, okay? Most of these are pretty straightforward, so I'm just going to kind of give you the answers. Number 10, I got a perimeter 30, area 32. Number 11, perimeter 16, area of 11.2. Number 12, when you sketch it out on the graph, is a 3x5 rectangle, so perimeter of 16, area of 15. Number 13 asks you to come up with the cost for each of these. Reminder that it was $8.50 per square foot. So I simply take my areas from numbers 10, 11, and 12 and get my dollar amount. So 10 was $272, 11 was $92.20, and 12 was $127.50. Number 14, I think, is the best one as far as stretches you a little bit. And it's because they give you the area of the shape and they give you the measurements, but the measurements are in terms of x. And so what you have to do is you have to think about formula. Your formula is base times height, or height times base, doesn't really matter, and that's going to be equal to area. And so you substitute the values they give you. So in essence, you have x times x plus 4, which is x squared plus 4x, equal to 45. We move the 45 over, and we get a quadratic function. Set it equal to 0, which is what happened, and then you can factor it. How do we factor it? Well, notice the minus sign here. So our c is negative, so I get a positive and a negative value. My b is positive, so my big number is going to go here. I'm looking for two numbers that multiply to 45. Listen, two numbers that multiply to 45 and have a difference of 4. Multiply to 45 and have a difference of 4. 9 and 5. 9 is the big number, so it goes here. 5 goes here, okay? Remember, there's no such thing as negative distance, so when I solve these separately, I'm going to get x equals negative 9, and I'm going to get x equals 5. The negative 9 is trash because we can't have negative distance, so x equals 5 for number 14. That's what they're looking for there. And then number 15 asks for you to approximate a drawing on a graph. And so I saw approximately a rectangle and a parallelogram. Rectangle's measurements gave me an area of 6. Parallelogram gave me an area of about 25. So 6 plus 25, I get 31. Okay, now what we're going to do is we're going to focus on area of triangles. 1/2 base times height, right? We're going to look beyond that, though. We're going to look at how do we deal with isosceles triangle. And in reality, the trick here is when they don't give you the height. So we're going to look at isosceles triangle and how to find the height. We're going to look at equilateral triangle. Equilaterals are awesome, and you can solve those only knowing one measurement, and you can always find height. It's kind of cool. And then eventually what we're going to get to is actually finding a formula where you don't even need the height of the triangle, but we're not there yet. That'll be in the next video. So let's start with the isosceles triangle because it's a little more complicated. Isosceles triangle, if we know all three sides of an isosceles triangle, we can find the area of it. And the way we're going to do that is we're going to divide right down the middle here. We're going to draw a perpendicular bisector. We're going to cut that base in half. My base here was 6, and so what's half of 6? Well, half of 6 is 3, and then my length here was 10. So in order to find my height, remember my height's there in the middle, in order to find my height, I'm going to use Pythagorean theorem, and since I'm looking for one of the legs, it's going to be the square root of c squared minus, in this case, 3 squared. So it's going to be 10 squared minus 3 squared, or h is going to be equal to the square root of 100 minus 9 of 91, okay? Now, what is the square root of 91? Here's the beauty. I just don't care. The square root of 91, it's not a perfect square, okay? It's probably about 9.4, 9.5, whatever, but I don't care. That's close enough. Square root of 91 is actually exactly correct, and I'm going to use that in my formula. What's my formula? 1/2 base times height. So if I want the area of this triangle, the area of the triangle is going to be equal to 1/2 times the base. How big is the base? Remember that 6 times the height. In this case, we have square root of 91. Now, what's awesome here is that's as far as you've got to go. Simplify that. 1/2 of 6 is 3, and then square root of 91, and that is your final official best answer. Okay, so don't stress about the 91. It does not reduce. Okay, so that's isosceles, and you can do that with any isosceles. Whatever this number is, you cut it in half here. You use this number and this number to get this number with Pythagorean theorem, okay? It's going to work every time for isosceles. Doesn't matter if it's acute, obtuse, whatever. All right, let's talk equilateral. Equilateral is even easier. Why? Because when I draw my line down the middle here, watch what happens. I create two 30, 60, 90 triangles, okay? Because remember, equilaterals are also equal angular. So this angle is 60, this angle is 60, this angle is 60, but that angle got cut in half. So now that angle is 30, all right? Which means my shortcut, my side length of x, side length of 2x on the hypotenuse, and side length of x root 3 is going to be true here, okay? How do I use that? Well, if my outer edge of my equilateral triangle is 2x, what's half of that? Well, it doesn't matter. If it was 8, then it's 4. In this case, it's 8, then it's 4. It could be 10, it could be 97, it doesn't matter. You're just going to cut it in half. That gets you your x. Why do you need your x? Because you're just going to multiply whatever your x is times the square root of 3. So what's half of 8? That means this length here and this length here match. This is 4 and this is 4. And that means the height of this triangle is 4 square root of 3. Okay? In fact, for an equilateral triangle, the height is always going to be equal to half of the side times the square root of 3. Okay? It makes it very easy. So when you're finding the area for an equilateral triangle, we'll go ahead and write it out. The formula is 1/2 base times height. So for this one, let's just go with the numbers we have. So 1/2, the base would be 8, and the height is 4 root 3. So 1/2 8 is 4, 4 times 4 is 16, so 16 root 3, okay? But what we can do is we can take this idea, knowing that a side length for an equilateral triangle is always going to be the base, so we can put half the base times the square root of 3. And you could plug that in for h, and watch what happens. We're going to have a half times the base times a half of the base times the square root of 3. What happens? We get b squared, or in reality, we'll write b squared to start, but then we'll talk about that. That and that will get us a 4, and then we get the square root of 3 over here. But where did the base come from? It's just one of the sides. So in general, you'll see for the area of an equilateral triangle, you'll see s root 3 over 4, and the s is squared. That works for every equilateral triangle. You don't have to memorize this. If you do, great, you can use it. If you don't, that's okay. So this is going to get you prepped for the 2 questions I'm going to give you. The one thing that you need to dig up from your memory box is geometric mean. There's going to be a problem I'm going to give you here in just a moment that's going to require you to use geometric mean. Reminder, geometric mean, when you have a right triangle, let's say you have a right triangle like this that's been laid over, and that would be our 90-degree angle. When you draw this altitude right here, the geometric mean is going to be such that a times b is equal to the square root. Sorry, a times b is just equal to c squared. Okay, and so what you'll see in your book is a times b, the square root of which is going to be equal to c. All right, and so you're going to need that on number 7. What I want you to do, take 7 minutes, go do question number 3, which is actually on page 437, and then let's do question number 7. So jump over to page 438, and we're going to do question number 7. All right, and I'll see you back in 7 minutes. Good luck.